In Lesson 50, we'll be learning about polynomial equations, ordered pairs, and the Cartesian coordinate system. Now, in Lesson 48, we learned about what a polynomial is, and basically those are just algebra expressions that have the form a x to the n, where a is some real number, and then x is the variable, and it doesn't have to be an x, but just for that example, we'll call it x, and then it has a power that is an integer. It can be -0 or a positive integer. Now, a polynomial equation, that means it will have an equal sign in it, and it could be something like this. Or it might have more than one variable in it, like that. The first one there, we would call that a third-degree polynomial equation because there's that x cubed in there. And then the second one, we'd call that a second-degree polynomial equation. What we'll be working with right now are first-degree polynomial equations that have two variables in them. And for example, let's just use this, y equals 2x plus 1. Now, when we're dealing with two variables like that in an algebraic equation, there have to be two solutions then, or a pair of values there, one for the y, one for the x, that would satisfy that equation or make that equation a true equation. For example, if we substituted x equals 1 into that equation, we'd have y is equal to 2 times 1 is 1 plus 1, or 3. So for that particular equation, when x equals 1, y equals 3. And so there's a pair of numbers there that have to go together. X has to be 1, y has to be 3 to satisfy that equation or make it a true equation. Now remember, in Lesson 28 we talked about functional notation, and we could have written this problem f of x equals 2x plus 1, and then we could have said f of 1 is equal to 2 plus 1, or 3. That functional notation, it just helps us keep up with our pair of numbers here. X is 1, f of 1 is equal to 3, and in this case we're just saying y. Remember that functional notation is just a symbol. Just like y is a symbol or a variable, f of 1 is also a symbol. But for a polynomial equation like this that has two variables in it, you will have to have a pair of numbers, one for the x, one for the y, and only that pair will satisfy that equation. Now there are other pairs that would satisfy that equation. It's just that when x equals 1, you have to use y equals 3. You can't use y equals 4 or something else. It has to be 3. And the reason for that is because the value for the y, it depends on what you put in there for x. For example, if we said x equals 2, let's just write this with functional notation. We would say f of 2 is equal to 2 times 2, or 4, plus 1, which is equal to 5. So in that case, y is 5 when x is 2. So the value for y, it depends on what value you put in there for x. Y, therefore, we can consider that the dependent variable, and x is the independent variable. Now, usually we consider the dependent variable as the one that's by itself in a polynomial equation. So like in this example, the y is by itself. And you'll be working with a lot of polynomial equations that are set up like this, where you have two variables, one of them is y and one of them is x, and y is the dependent variable. Now what we've been discussing about the dependent and independent variables, that leads us to our next section on ordered pairs. And like I was saying, the value for y, it depends on what you put in there for x. X is called the independent variable. And to make this polynomial equation a true equation, you have to have that pair of values, one for x, one for y. That's what the ordered pair is called. And so usually that is written with parentheses, and you put the x value first and then the y value second, x comma y. So one ordered pair that satisfies that y equals 2x plus 1 equation would be 1 comma 3. Another pair that satisfies it is 2 comma 5. So that independent variable in this polynomial equation is the x value. It's independent because it doesn't depend on what y is in order for it to have a particular value. You put the value in there. It could be a 1, a 2, it could be a negative 10, it could be a 5.73. But whatever value you put in for x, there's only one y value that will go with it. Now there's something really interesting that you can do with these polynomial equations like this that have the two variables in them. And you can actually make a graph of their relationship. The way you do that is by using something called the Cartesian coordinate system. And you've probably seen this before. In fact, if you did algebra half, I'm sure you've seen this before. Basically, it's just two number lines, one perpendicular to the other. They intersect each other at 0. And so you can just put some tick marks on them. To the left is negative, to the right is positive on the x-axis or horizontal axis, and then the vertical axis, which is considered the y-axis, above the horizontal, that's positive, below is negative. And what you do with this Cartesian coordinate system is you can plot these ordered pairs from a polynomial equation like the one we've been talking about. And so, for example, if you took that ordered pair 1, 3, you would you start at the origin there, move to the right 1, and then up 1, 2, 3, and you place a point right there or a dot, and that represents 1, 3. Now you don't have to draw those lines that start from the origin and go to the right and up. I'm just doing that so you can show the path that I'm following. And in fact, I just went ahead and erased those lines so you don't think that that's something you're supposed to do every time. And so that point that we just put on there, that represents the ordered pair 1, 3. Go to the right 1 and up 3. We could also do 2, 5. We just start at the origin again, go to the right 1, 2, and then up 1, 2, 3, 4, 5. And it would be right here. And so that represents 2, 5. Now, when we work with the Cartesian coordinate system, you can kind of see there's 4 sections to it, or quadrants. This one on the right is called quadrant 1. Then this one on the top left is quadrant 2. This is quadrant 3. And this is quadrant 4. Now, in each one of these quadrants, the ordered pairs, they have specific signs that they will have, like plus or minus signs to them. And so we can just go ahead and represent those. In the first quadrant, x and y are both always positive. In the second quadrant, x is negative and y is positive. In the third quadrant, they're both negative. And then in the fourth quadrant, x is positive and y is negative. Just notice some relationships there. Notice how the quadrants that are diagonal to each other, their signs are opposites of each other. Like you have plus plus at the top right, negative negative at the bottom left. So the Cartesian coordinate system, that helps us organize information that we can collect from a polynomial equation with two unknowns in it, or two variables in it, like the one we were talking about here, the y equals 2x plus 1 equation. Let's go ahead and do some practice problems now. And basically I just want you to plot those points in A, B, C, and D. So if you want to, you could make yourself a Cartesian coordinate system. You could do it on graph paper if you're not real comfortable about making tick marks equally spaced apart, or you can just draw one on your paper that you have there. I would go ahead and pause the CD, make a Cartesian coordinate system, and see if you can plot all those points. Turn the CD back on and see if you got them correct. So the first one there is 2, 2, or positive 2, positive 2. And remember, when we're thinking about ordered pairs, x is first, y is second. So that means we would go to the right 2 and up 2, and our point is right there in the first quadrant. First quadrant, both of the numbers in the pair are always positive. B is negative 2, 3. That tells us that we're in the second quadrant because the first number is negative, the second one is positive. So we go to the left 2 and up 3 and put our point right there. And that would be -2, 3. I'll go ahead and label these. This one's A, this one's B, just so you can kind of keep up with them a little bit better. C, that would be in the third quadrant because both of the numbers are negative. And so -1, we go to the left 1 and down 1, 2, 3, 4, and put our point right there. And so that would be C. D is 0, -6. So if it's 0, that means we don't move anywhere in the x direction. We just go straight down -6, and that would be right here. And so that's D. Now our last problem there, it says if f of x equals 2x plus 3, find f of -1 and plot the ordered pair. Okay, so in that ordered pair, let's just think about this. We're going to have x comma y. I'll just put some parentheses and a comma. We know what x is. It's -1 because we're trying to find f of -1. F of x is going to be f of -1. And so we just substitute that in. If f of x is 2x plus 3, then f of -1 is 2 times -1 plus 3. And so that would just be -2 plus 3, which equals 1. And so that's what f of x is, or basically y. And so we would just put a +1 in there for our ordered pair. Remember we talked about that earlier. That functional notation, it's just a symbol. It could be the same thing or mean the same thing as y. And actually it does mean the same thing as y. It's just a different symbol than y. So -1, 1, that's our ordered pair. Let's go ahead and plot that. We'd go to the left 1, up 1, and it would be this white dot right there. That would represent the ordered pair that we have described when x is -1. So in a polynomial equation like that, there is an ordered pair and there's a specific ordered pair. There has to be one particular value of x that matches up with one particular value of y to make that polynomial equation true. Okay, well that's all for lesson 50.